Let's do a numerical version of the ISLM model. We have on the IS side, we have 5 equations. The planned expenditure equals consumption plus investment plus government spending plus net exports. We have a numerical consumption function, some numbers for the investment function, depends negatively on the interest rate. Government spending is exogenous, and net exports depends negatively on GDP. We import more the higher GDP is. Then we have the LM side, money demand is depending positively on GDP and negatively on the interest rate. Money supply is fixed, the price level is fixed, so real money supply is fixed. We take those equations and we simplify on the IS side. We get this long expression here. And now we have a bunch of terms with y in them, and that 0.64 is, if we go back, that's this 0.8 times 1 minus 0.2 is 0.8 times 0.8 is 0.64. So we have 0.64 and then minus 1/4, so we have 0.5, which we then bring over to the other side, so that's why we have a negative sign there. And so we have y minus 0.5 equals 140 minus 2r, and then we y minus 0.5 is 0.5y, so that's a half y, so we multiply everything by 2, so we get y equals 280 minus 4r. So that's our IS curve. Our LM curve is pretty simple. If we go back to our LM equations, we just have 200 equals 2y minus 10r. So 200 equals 2y minus 10r. So now we can solve this by substituting. We put the y from the IS curve into the LM curve. So we have that over here. 200 equals 2 times 280 is 560. 2 times minus 4y is minus 8y. And then the minus 10y here. So we have 10r, I'm sorry. So we have minus 360 equals minus 18y, and our solution then is r equals 20, y equals 200. We can plug those back into the LM curve and the IS curve to double check. We could go back to our original IS equations and make sure everything was consistent. That level of GDP, planned expenditure, should be equal to GDP. So we could plug that all in and verify. We can graph this. So our LM curve equation is 200 equals 2y plus 10r. So if r is equal to 10, then y would be equal to so that would be 100. So y would have to be equal to 150, right? So that's why we have y here. If r were equal to 20, we plug that in here. That would be minus 200. Bring that over to the other side. We have 400 equals 2y, so y is equal to 200. So those are 2 points on the LM curve. We know it's a straight line, so our LM curve looks like that. For our IS curve, we have y equals 280 minus 4r. So we can say, well, if r is 10, what will y be? It'll be 240, so that might be some point out here. If r is 20, what will y be? Well, 200. If r is 30, what will y be? Be something like 160, so that might be some number here, and that's our IS curve. And we could continue, right? The IS curve is the set of all the curves where y is equal to 280 minus 4, the set of all the points where y is equal to 280 minus 4r. So that's our graphical and numeric solution for this particular problem. The usual thing we might do with something like this is to say, suppose government spending increased by 10, what would be the new equilibrium level of GDP and interest rate? And I'll leave you to figure that out.